Okay, guys, we are in Algebra 2, Mod 8. Today's date is 4/28/20, so it's what, Tuesday, April 28th. Hopefully you're keeping up with our little 15-minute video per day, getting your homeworks turned in on time. We're at the fourth and final day of our trig introduction chapter. It was critical that you got introduced to some basic trigonometry with good old SOHCAHTOA heading into next year, no matter which class you're taking. It's also good for the ACT that you're all going to take, hopefully, at least one more time. So again, today we're in Algebra 2, Mod 8. Today's date, Tuesday, 4/28/20. The title says Trig Applications. We're trying to just put together some real simple, real-life little scenarios where you would have to use, let's say, as a surveyor to figure things out as to angles of elevation and distances and things like that, and try to apply the SOHCAHTOA we've learned to some real situations. So all we're going to do today is do 4 basic little problems where I'm trying to apply what we've learned, again, to real-life situations. And you're just going to make a quick little sketch of each scenario as I talk about it and describe it, and then we'll attack it and try to answer the question. So if you can divide your paper into 4 parts for the notes you're taking, we're going to do 1 picture and 1 problem in each block. Big deal. Okay? Block 1. Let's just do this. We've got a tree, and let's say up in that tree there's a tree house, and there's a ladder. That's what the little marks are here for. There's a ladder leaning against that tree that's 13 feet away from the tree. So guys, draw a quick little sketch. Make a tree. Make a ladder that's leaning against that tree. That's the base of the ladder, touching the ground, is 13 feet away from the tree. And this 50 degrees is called, you might have had this if you've had science classes dealing with angle applications and things like that. This is called an angle of elevation. It's 50 degrees if you can't read that. I've got a 50-degree angle of elevation. So in other words, if you're standing here at the bottom of that ladder, ready to climb up that ladder and get to that tree house, your head is looking up. Your eyes are looking up at a 50-degree angle to look up at the treehouse and look up at the top of the ladder. Okay? Obviously, this ladder leaning against a tree is a what? Right triangle situation. They want to simply know on our question, how long is that ladder, or how tall is that ladder? I could have said how tall is the tree, couldn't I? I'm asking, how long is the ladder? Now, the key on these, of course, is whatever you're trying to find, put an X there because it's your unknown value. Agreed? If we want to know how long is that ladder's length would be our X, our unknown value. So using trigonometry, good old, I'll write it down again. Our favorite word from the last few days here, good old SOHCAHTOA. If I start here at this 50-degree reference angle, kind of like what we did yesterday, remember? I am not going to use the opposite side, am I? Because we don't know anything about the height of the tree. I am going to use the adjacent and the hypotenuse. Agreed? Because I'm using the side right next to my reference angle. And of course, the side that's across from the right angle. So adjacent over a hypotenuse is which one? Isn't that cosine? When we look at SOHCAHTOA, cosine is adjacent over hypotenuse. Think with me on these. Don't just copy stuff down. You got to think your way through these when you try them for homework. So guys, I'm going right here to my reference angle. We're going to write the cosine of 50 degrees equals... And you got to go adjacent over hypotenuse, right? Follow the bouncing pen. Adjacent over hypotenuse, 13 over x. Now careful, the x is on bottom. So when I put this over 1, I would cross multiply and get x cosine of 50 equals, isn't 1 times 13, 13? So now to get that x all by itself, I divide by the cosine of 50. Those would cancel. So on your calculator, we'll go to the nearest tenth because it's just the size of that ladder. Calculator's out. Make sure you're on degrees. You're going to push 13 divided by cosine of 50 and get 20.2. I guess we should label it 20.2 feet is how long that ladder would need to be. Okay? Look at number 2 here. Again, just draw or sketch a tree. We've got the sunshine up here shining down on that tree. So the sun is shining on the tree. And since the sun is shining down on that tree, it's casting a shadow, isn't it? Now, guys, it's not true that however tall you are, or however tall in this case the tree is, the shadow does not have to be the same size as the height of the tree. It depends on the angle of the sun. Would you agree? So all we're doing in this simple scenario, of course, our right angle would be in that corner where the tree meets the ground. I've got a 20-foot tall tree casting a 26-foot shadow from the sunshine that's shining down on that tree, and the shadow extends to this point right here. Agreed? All they want to know is, hey, this time, instead of finding the missing side like that ladder, what is the angle of elevation? So if you're standing out here at the end of that shadow and you had to elevate your eyes and your eyes looked up to the top of the tree towards the sun, what would this angle of elevation be? Okay? So that angle, of course, is our reference angle. If I asked you what sides are we working with, okay, we're not going to work with the hypotenuse, are we? Because we don't know anything about it. We're working with the what? Follow the bouncing pen. The opposite and the adjacent. Opposite over adjacent is what? Tangent on your SOHCAHTOA idea. So guys, opposite and adjacent, tangent of... Now, we don't know how big this angle is. Let's call it angle A. That's fine. The tangent of angle A is, and then we got to go opposite over adjacent. So that's 20 over 26. Remember, we're looking for a missing angle, and we practiced this the last 2 days. How big would angle A be? Don't push tan. What are you pushing since we're looking for a missing angle? You're pushing what? Second tan, right? Inverse tan. So on your calculator, hit second tan, 20 divided by 26, and you should get to the nearest tenth, 37.6 degrees for my angle of elevation. Okay? Third picture you're going to sketch. Okay, no big deal. Draw what looks like an upside down right triangle here. We got Mike's house, we got Joe's house, and we got Sam's house. Okay, you start at Mike's house. He's going to drive in his car to Joe's house. They're going to drive from Joe's house to Sam's house, and it's an 8-mile drive. All I want to know, if the angle from Mike's house to Sam's house, which normally would be kind of our angle of elevation like we've been talking about, if that angle's 36 degrees, and the distance from Joe's house to Sam's house is 8 miles, how far is it, do you think, from Mike's house if he drove directly to Sam's house? So Mike's thinking, the heck with Joe. I don't want to drive all the way to Joe's house and then 8 more miles to Sam's house. I just want to drive straight to Sam's house. How far is that distance? So that's going to be our x. Agreed? Knowing that this is now our what? Our reference angle. What sides am I working with? Well, I'm not going to work with the side right beside it, am I? I'm going to work with the what? The opposite and the hypotenuse. Which one's opposite and hypotenuse? That's sine, isn't it? So you got to know your SOHCAHTOA. The sine of 36 degrees equals, and you got to put it in the right order, opposite over hypotenuse, so that'd be 8 over x. Once again, the x ends up on the bottom. Put him over 1. Cross multiply. I get x sine 36 equals what? 8. To get x by itself, I divide by the sine of 36. And using my calculator, I'm pushing 8 divided by sine 36 and getting 13.6, what would that be? Miles, right? If we labeled it, 13.6 miles from Mike's house straight to Sam's house, okay? And finally, we got a cliff, a 42-foot tall cliff. At the top of that 42-foot tall cliff, there's a bird, and the bird looks down and sees a boat out here on the ocean, okay? So big deal. We've got a 42-foot high cliff. The bird is standing on top of the cliff. He sees a boat. And that boat, by the way, there's a 58-degree angle in there between the top of the cliff to the boat. How far is the boat from the cliff? So if this is the boat, here's the ocean, and there's the base of the cliff. How far is the boat away from the cliff? So if my right angle's there, this is going to be my x. Agreed? And I start up here at that 58 degrees because I got to have a reference angle. Okay, now think about it. You're not going to use the hypotenuse, are you? Because the hypotenuse, notice, is empty or blank, isn't it? So if we use this as our reference angle, what sides are we working with? The opposite and the adjacent, which is, again, what word? Wouldn't that be tangent? Opposite over adjacent? So the tan of 58 degrees equals x over 42. He's understood to be over 1. When I cross multiply this time, notice the x is on top. So 1 times x is just x. So in essence, all I'm doing on my calculator, right, is pushing 42 times tan 58. And that's going to be my answer. So I'm going to go to my calculator, hit 42, tan 58, enter. And it looks like I'm getting 67.2, and then that was what, feet? It's 67.2 feet from the boat to the cliff. Okay? So there's all kinds of little scenarios where you're drawing real-life pictures and can apply all your SOHCAHTOA trigonometry stuff to find the missing sizes and lengths. Okay, I hope that makes sense. Your homework is to try 4 problems just like this. Now, guys, your 4 problems are similar to what I just did. You don't have to try to pause and look and read it off this version, this lesson. I attached on Schoology a worksheet, a Word document that has all these problems neatly listed and written out for you, okay? When you go to your Schoology, go right underneath the video you just watched or are watching, and right underneath the video for 428, the lesson, it says 428 homework, okay? So go to that document on Schoology for 428 and call up on your screen the homework for tonight. Probably be best to just print it out if you can. If you print out that document, you can then just do the homework problems right on the sheet and then take a picture of it and show it to me or email it to me, okay? So you've got 4 problems tonight. They're found on Schoology underneath today's lesson that you just watched. Call that document up. Either print it out or just look at it. Do your 4 problems. They're going to be due tomorrow, which would be what? Wednesday the 29th by noon. And see if you can do some trigonometry applications. Great job, guys. We'll see you then.